All right, we're going to have a look at example 6, and we're going to take some numbers and we're going to classify them to include which number sets they belong to. So we're going to either have n if it's belonging to natural, w if it's whole, I if it's an integer, q if it's in the rational numbers, q with the bar over it if it's in the irrationals, and oh, here I didn't write. And funny special written R for real numbers. They kind of fancy it up. But if you just write R, I'm fine with that. So in example 6, we have to look at the number -4 and decide which number system it belongs to. So I start at the top and work my way down. Is it a natural number? Does -4 get included when I start to count numbers starting at 1, 2, 3, 4? No, there are no negatives there. So it's not a natural number. I look at the whole numbers. Is it in the list 0, 1, 2, 3, 4? No, there are no negatives in there. So the first number system that includes negatives would be integers. So -4 belongs to the integer number system. If I look at rational, remember it's only going to be one of rational or irrational. -4, as it's written, terminates. If I want to think of it as a fraction, it's -4/1. So if it's able to be written as a fraction, then we say it belongs to the rational number system. So that number system, remember, is Q. So it can't be irrational. Every number that we know so far that we've studied is a real number. So it's included in the real number system. So if we have a look at our Venn diagram here, it shows you how the number systems kind of build on each other. So -4 is not in the naturals, it's not in the wholes. It's in the integers, it's in the rationals, and it's in the real number system. All right, let's look at the cube root of 27. Well, the cube root of 27 is really the number 3. The cube root of 27 has a value of 3. If I look at 3, 3 is in the list as a natural number. 3 is also in the list as a whole number. 3 is also in the list. It's an integer. Then I have to decide, is it rational or irrational? Well, the number 3 terminates. Or I could say it's 3/1. Either way, it would be a rational number, which means it can't be irrational now, and every number we've known so far is a real number. Part C, we're going to take the fraction 3/4, and we're going to have a look, where does this start? Well, natural numbers have no decimals and no fractions, and I know that 3/4 is 0.75. So it's a fraction and it's a decimal. So I have to jump all the way to the first number system that says it includes decimals. That means rationals. So I have to have a look. Is it rational now or irrational? If it can be written as a fraction, 3/4, then it's rational. So it can't be irrational, but it must belong to the real number system. And the last one is pi. Pi, if you remember, or press the button on your calculator, is 3.14159, and it continues on. And we know of pi from our grade 8 studies, it doesn't terminate and it doesn't repeat. Pi is the first irrational number that we're introduced to. So it's not rational, but it is real.